So here it says that the number of factors of the square of a number is 135. So n squared, if you look at it, we'll have the number of factors as 135. So it would have some prime numbers. The powers of those prime numbers, we add 1 to that and multiply, that gives us 135. So let's factorize that in the lowest form. So 135 is basically 5 times 27. So 5 times 3 times 3 times 3. The way in which we have got here must have been like 4 plus 1 times 2 plus 1 times 2 plus 1 times 2 plus 1. That means the most the least form, or the best form in fact rather, that we can break this down into, like we can't break it any further, would be if you have 4 primes whose powers are a to the power 4, b squared, c squared, d squared. This would give me n to be a squared, b1, c1 and d1. Now they're asking for the cube of this, so n cube would be a 6, b cube, c cube, d cube. And the number of factors of this will therefore be 6 plus 1, 7 times 4 times 4 times 4. So that's 7 times 64. And that's 448. So the answer is option 2. Now you might say that why is it that if you break it to the lowest form, the most form, I mean, you can't break it any further, that gives us the maximum. So if you decide that no, let us think of some other case which can also give us. So 135 can be written by itself as 134 plus 1, right? Basically meaning I'm taking the look at the other extreme, that n squared is a to the power 134. That would mean n is a to the power 67. So n cube would be a to the power 201. Hence it would have 202 factors, which is way less than what we have got here as 448. So when we broke it, we did not break at all. We said that there is only one prime. Then we have fewer number of factors. And when we broke it down to the case where we have the most number of prime factors, then we have the highest number of factors for n cube. So the answer is option 2.